Welcome back, everybody. So the next question is trapping rainwater. This question is very important question. Actually, most of the companies ask this question. First time it was asked in Google, I guess. So let's read the statement. Let's analyze what is the problem. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So you have to compute the total amount of water which can be accumulated in between the bars. Like for example, first height is 0. Okay, this is 0. Then it's 1. Then it's 0. And then it's 0. Then it's 2. So you can clearly see that okay, this amount of water can be in between this bar and this bar. Now going to this, okay, then you can see that okay, this amount of water here, the total amount of water will be 6. Okay, similarly in this case as well. So now let's analyze the solution. I think you understand what is the problem statement, what you have to return. You have to return the total amount of water which can be accumulated in between the bars. Okay, let's look at the statement, look at the solution. I will simply tell you, okay, simple words. I will give you some examples and just go. Okay, now suppose there is one bar. Now tell me what is total amount of water above this bar. That is 0 because it will overflow from the left hand side and it will be overflow from the right hand side. So there is no water. Now suppose if I like there's some any bar which is more than this height, and on the right hand side our total amount of water above this bar will be like this. Okay, here we have 3 bars, and if I want to compute the amount of water above this bar, okay, I'm just considering this bar only, so it will be equal to this one. Okay, so now let's analyze one more situation here. Now I just sorry for my drawing. Feeling very good at drawing, that's why. Okay, now what is the total amount of water? I think you'll say that okay, yeah, this is the total amount of this. So what do you analyze in this situation? What do you analyze in this situation? You will see that amount of water on the above bar on this of this bar will be like height of the water level will be equal to this. In this case, will be equal to this according to this bar. So the height of level water, the height of the water above this bar is will be according to this bar. Okay, and in the above case, it will be according to this bar. So okay, I think you can visualize it. Now let's analyze one more question. Sorry, one more example. You have this bar as well, and you have like one more bar greater than height is, and I have one more bar. One bar here like this. Now, if I consider this bar and want to know what is the total amount of water above this bar, will be equal to will be according to this bar. Okay, this bar. You can see that. You can see that amount of water will be. Just I am considering about above this bar. Okay, this will be. So you will clearly analyze that the amount of water for any bar. Suppose this is ith bar. Okay. So what I will do, I will go on the left hand side and I will check the what is the maximum height on the left hand side. Like suppose the maximum height on the left hand side is HL, which is greater than or equal to this height. Okay, maximum height which is greater than equal to current bar will be HL. Okay, and also you have realized that for this case, and I will go in this case, it is according to right hand side in this case for the first case. So I will go on the right hand side and I will try to get the maximum height which is greater than equal to current bar. Okay, Now if you will see the amount of water above any bar, above the ith bar, will be equal to minimum of maximum height on the left hand side and the right hand side. Okay, the height of the water level above any bar will be equal to the maximum of maximum height on the left hand side and the maximum height on the right hand side, and the minimum of both, minus the current bar height. Current bar height. Okay, that will be my amount of water, the height of water above any bar, into the width of bar. So width of bar is 1, so that does not matter. The main thing you have to calculate this. Okay, and simply add for every bar. Okay, for every ith bar you have to do for this and simply add them. I think you understand what I want to say. Okay. Suppose in this case, what is the minimum on the, what is the maximum height on the left hand side? This is the maximum height on the left hand side, and what is the maximum of right hand side? This is the maximum on the right hand side. Okay. And what is the minimum of both? Minimum of both is this. So the level of water will be like according to this bar. So this minus current HL, that is this height. So the remaining height will be like this into width of the bar, that is 1. Amount of water above this bar is equal to this. Suppose in this case also, the maximum height on the right hand side is this, and the minimum of both is this. Simple. And in this case it is okay. I think you understand the logic. So we are going to implement the logic. So no, okay. Let's analyze the time complexity as well. So the time complexity will be like, suppose if you are on the ith bar and you are going to find the maximum height on the left hand side and you're going to find the maximum height on the right hand side. So for every I you are going to traverse n. Okay. So the time complexity will be n square. Okay. So I think, can we reduce it? So this is another method where we can reduce it by taking extra space. Okay. So what we will do, we will pre-compute the left height and the right maximum height. Okay. So after pre-computing it, and then we will store it in the array and simply perform this operation for every I. So then my time complexity will be O of n and my space complexity will be O of n. I will tell you how we will pre-compute it. Let's go check the solution. So I told you we will pre-compute it. So suppose I will take to store the left height. I will check. Okay. Yeah, we'll just HEI sorry, n equal to HET dot size. Okay. And left of n comma RIGST right of n. Okay. I have declared the left and right. Now how will I calculate the left and right height for every bar? So what I will do, I will run a for loop int I equal to 0 comma I less than n comma I. Okay, simply what I will do, for current I will take one max left height, max underscore left equal to I and t underscore min. Okay, so what I will do, I will left of I equal to max of current, that is HEI HEIGST of I comma max of max underscore left. Okay. in math, so max underscore left. Simply, or you can do it like max underscore left equal to this, and left of I equal to max underscore left. So like this. I will just simply whatever. Again, do it for the right height equal to n minus 1 greater than equal to 0, and then I minus minus. And I will declare max underscore rigst right equal to int underscore n. So I will do like this: max right then I will do right, then I will do max t right. So for suppose if I am at this position 0 position, then max height is equal to 0, then I will go this position, the max height is equal to this, then I will go this position, then the max height is equal to this. Okay, for this position, then again max height will be equal to this. So in this way, for every I will be just storing the maximum height on the left hand side as well as on the right hand side. Now you got this array, sorry, right array RIGS. Now I'm going to calculate the area, total amount of water. Total amount of water is total loss of flow. So I will go n total underscore water equal to 0 for loop, and I equal to 0 comma I less than n comma I. Sorry. Yeah. Every total underscore water is equal to total underscore water plus, okay, total underscore water plus I will do minimum of left of I comma right of I minus, okay, minus what, current height of I. Okay, simple, easier to understand. Now you have to return the total underscore water. Let me check. So I'm not multiplying it with the 1, okay, because width of the bar is already 1, so it doesn't matter. Right, minus I this water plus what this. So let me check. Okay, max underscore left. Okay, I'm sorry. I think I thought I have declared it earlier. So it's accepted. No. Yeah, it's got accepted. I think you understand what I'm doing and what is the solution here. Yeah. Simply what you have to do. So for example, so what this will do. So pre-computing will just reduce my time complexity. Okay. So I have done the pre-computation for the left and the right. And simply, I think you for main thing you have to understand this logic. What is this logic? So now again I'm telling you. Let's watch here. So what is total amount of water above this bar? Okay, I'm just considering this bar above this bar. So it will be equal to the maximum of left hand side, that is this. Okay, this one, this bar, and the right hand side maximum, that is this bar, and minimum of both. Okay, minimum both this. So level of water will be like according to this, the amount of level of water simply minus the current bar. Get the answer above this water. So in every I, for every ith bar, you have to just calculate the amount of water amount of water above that bar, and simply add the water and you get the answer. So it's very important question, and most of the company ask this question. And just go through this question thoroughly, and you'll be good to go. Thank you. Bye bye. Thank you for watching this video.